Assalamu alaikum wa rahmatullahi wa barakatuh. Welcome to Linear Algebra course. In this video, we will talk about Gaussian elimination and programming. So, before we start our presentation, let me present to you the agenda for today's presentation, starting with introduction, talking about Gaussian elimination and programming, and then move into Gaussian elimination, and I'll give a quick definition about it, and then move into Gaussian elimination applications by giving quick brief definition about each one of them and give solved equations for each one of them. And lastly, we will conclude this presentation. So, starting with an introduction. Math is the cornerstone of many applications in real life, especially in programming. We can see the use of linear algebra clearly in several applications in programming, such as machine learning, data analytics, and physics simulation. This research is set to prove that linear algebra, especially Gaussian elimination, are a base in the process of programming. In addition, show that Gaussian elimination simplifying the programming process. So, moving on to the Gaussian elimination law. Gaussian elimination law divided into three concepts. The first one is convert the matrix into the augmented matrix form, which is write the system of linear equations in matrix form, including the coefficients of the variables and the constant on the right hand side. And after that, solve the system by forward elimination or back substitution. So, forward elimination use row operations to make all entries below the main diagonal 0. This creates an upper triangular. And then back substitution, which is solve the upper triangular matrix for the unknown variables starting from the last row. Now let's start with the first Gaussian elimination application, which is physics simulations. Physics simulations are computational models that replicate the behavior of physics systems, allowing us to predict how objects interact in different environments based on physical laws, such as Newton's laws, thermodynamics, and electromagnetism circuits. And these simulations are widely used in fields like engineering, video games development, circuits, and scientific research to model real-world phenomena such as motion, fluid dynamics, and particle interactions. And now moving on to the second Gaussian elimination application, which is machine learning. Machine learning is a field of artificial intelligence, or AI, that enables computers to learn from data and make decisions or predictions without being programmed. In other words, the machine learns by itself without human interaction. So it relies on algorithms that identify patterns within data and use these insights to improve over time. Types of machine learning includes the following. Supervised learning, where the model is trained on labeled data, and unsupervised learning, where the model tries to find patterns in unlabeled data. And the last type is reinforcement learning, where the model learns by interacting with an environment and receiving feedback.
Data analytics is the process of examining data set and draw conclusions and identify patterns. It involves techniques like statistical analysis, machine learning, and data visualization to make sense of raw data. However, data analytics is widely used in fields such as business, healthcare, and engineering to optimize operations, predict trends, and solve complex problems. Let's move on to Gauss elimination in physics simulations. As we can see here, we have an electrical circuit where R1 equals 10 ohms and R2 equals 20 ohms and R3 equals 30 ohms, in addition to two voltage sources, where V1 equals 10 volt and V2 equals 5 volts. According to Kirchhoff voltage law, we have two equations in loop 1 and loop 2, where V equals IR. And the third equation will be, according to Kirchhoff current law, I equals I2 plus I3. We turned our three equations to augmenting matrix and then solve it by using Gauss elimination, and we get the value of I1 and I2 and I3.
Okay, Gaussian elimination in machine learning. Linear regression is a supervised learning algorithm that models the relationship between a dependent variable, which is in this case y, and independent variables, which is x and z. The problem here is to predict the price of house, which is variable y, based on two features, which is size, variable x, and number of bedrooms, which is variable z. As we can see here, we can see that there is three equations. Now we're gonna write the matrix based on the three equations. We will get this matrix, and we will need to simplify it, so we will multiply -2 in R1 plus R2 in R2, and we will get this matrix by multiplying -1 in R2 plus R3 in R3. And as you can see here, we can find that we can write the equation, which is 3z equal to 6 from the matrix above, and we will get that z equal to 2, and by subtracting we will find that y equal to 4 and x equal to 0. And now we will move to Gaussian elimination in data analytics. In this example, the company gathers data about customer behavior to predict whether they will return or not. The company has derived the following equations for three customers. Okay, and the variables here, x, y, and z, are weights for features like time, average purchase value, and interaction count. We will first write the matrix. As you can see here, this is the matrix from the above equations, and we will work on it and simplify it until we get the last matrix, which is 1 0 0 0 1 0 0 0 1, as you can see here. And in this matrix we can find that z equal to minus 0.6875 from the matrix, and y equal to 0.25 and x equal to 1.78. In conclusion, linear algebra is considered backbone for programming, especially Gaussian elimination. Furthermore, Gaussian elimination can help in many processes such as machine learning, data analytics, and physics simulation. And as we saw in the previous examples, we can use Gaussian elimination in these three applications. Lastly, future research, which is something very important, should focus on other applications of Gaussian elimination in programming, because most people focus only on the outputs and do not care about knowing the process that take place to get this output to them. That was the presentation. We reached the end of it, and thank you very much, guys, for listening. I hope you enjoy it and find it very important for you, and good luck.